All right, back in Math 1411, you talked about inverse functions. What do you remember about inverse functions? They're opposites. What do you mean they're opposites? Like 2 and negative 2? What are inverses? They're like flips of each other? No, one over the other one. That's called reciprocal. That's not inverse. All right, so I'll give you a nice simple function here. F of x equals 2x minus 5. You interchange the x's with the y's. All right, so we're going to call this y equals 2x minus 5. And then I heard somebody say switch the x's and the y's. X equals 2y minus 5. And then you get y all by itself. All right, so x plus 5 equals 2y. So y is x plus 5 over 2. And the symbol we would write for this quite often, you have to write it or the teacher takes points off. Yeah, I know her. She's mean like that. You write the symbol for inverse. So that's how you compute the inverse. But what does it mean? How do f of x and f inverse interact with each other?
Isn't it width over or it's its mirror image?
Okay, so they do have a mirror image property, yes, over the line y equals x, actually. It's not over one of the axes.
Oh, that's right. It's a slanted line.
Right, it's a slanted line. Mirror of y over x. But what about those two functions? Why are they called inverses? And what do inverses do? They cancel out. When do they cancel out? When you multiply them together?
Set equal to each other.
When you put one into the other, and the fancy math word for that is function composition. So if I do f inverse at x, O stands for composition. I take this one and I plug it into that one, and what should happen?
You would get 2 parentheses x plus 5 over 2 minus 5.
And when I simplify all that, what should I get? Everything should simplify down to be just x. So they cancel each other when you do composition. So the 2's reduce out, that's nice. X plus 5 minus 5, the 5's reduce out, I'm left with x. And it should work if I switch order. F inverse f. So now I take this one and I plug it in there. That's 2x minus 5 plus 5 over 2. That's 2x over 2. The 5's reduce out. Oops, the 2's reduce out. I get x left. So that's what it means to be inverses. What it means to do inverses is when you compose the two functions, everything reduces and you're left with the letter x. And the order in which you compose them doesn't matter. If you do f inverse or if you do f inverse o f, you'll get x both times.
What did you say was called?
Function composition.
Function composition? That's what this symbol stands for. This is the symbol for function composition. So when people say opposites, when they say inverses mean opposites, that's not really true, because opposites usually means like 2 and negative 2. And then they say divide one by the other. Well, those aren't inverses either. Those are called reciprocals. When we talk about functions and we talk about inverses, we're talking about function composition. Okay, what else do you remember about function composition in inverses? Anything? Okay. You can do f of g of h. You can do lots of compositions. That's true. All right, let me give you a different question. F of x equals x squared. What's the inverse of x squared? G of x is square root of x? It's not that easy? You don't trust me? Oh, that's discouraging. You don't trust her, though? She said the answer, not me. All right, so Mr. Cowles would like to solve. So he says y equals x squared. And then how do you get the x all by itself? Take the square root. So x is, oh, we forgot we got x equals y squared. I guess we should switch our variables, right? And then take the square root, you get y equals the square root of x. So I'm going to call this g equals square root of x. So if I do f composed with g of x, I would take this square root, I would plug it in there, I would have the square root of x, and then I would square it. That's just x. Okay? What if I switch the order? GOF of x. That would mean I start by squaring something, and then I square root it. What happens when you square something and then square root it? Cancel each other out? Okay. Start with the number 5. What's 5 squared? 5 squared is 25. And then I do the square root. Square root of 25 is? We don't have plus or minus written there. We only have the positive square root. So if I plug 5 in, 5 squared is 5, and then I do, or 5 squared is 25, and then I square root, I get 5. What if I plug in negative 5? What's negative 5 squared? 25. What's the square root of 25? 5. Did I get negative 5 back? Did I get the same thing I started with? If you square something and then square root it, you do not always get your original number back. What you get back is the absolute value. So, x squared and square root, are they inverses? No, they are not. So something's wrong. I mean, we did the process. We got the answer. What did we do wrong? When you square root both sides, how many square roots are there? There are 2 square roots. So when we did square root right here, we should have done plus or minus. When you do square roots, there are 2 square roots. Now we have a bigger problem. The bigger problem is this is not a function. Why is this not a function? You cannot get 2 answers. If I plug in x equals 9 and I have a function, how many answers can I get? I can only get 1. But if I plug in x equals 9 into that formula that I have written right there, how many answers do I get? 2, so that's not a function. Alright, so we have a problem. We have lots of problems with this example. What's wrong? Anybody remember there was a rule about inverses? Something had to be true in order to have an inverse. It has to pass the vertical line test to be a function. It also has to pass the horizontal line test. And what's it called when it passes the horizontal line test? 1-to-1. All right. So the overall big problem here was f of x equals x squared is not 1-to-1. Because we all know what it looks like. It looks like this. It does not pass the horizontal line test. Because if I draw a horizontal line, it can hit more than once. So what we had to do on a problem like this problem, f of x equals x squared, it was a trick question. This does not have an inverse. So when I asked you what's its inverse, the correct answer was there wasn't one. It's a trick question. Wasn't that mean? On a Monday morning, asking trick questions? Anyway, what did we have to do? To make it 1 to 1.
Only do one side.
Only do one side of it. So what we would do is we would erase this half. So the correct question and the correct answer is f of x equals x squared when x is greater than or equal to 0. That's the function I should have given you. Because now I'm only dealing with the right-hand side of that parabola. Now, does it pass the horizontal line test? Yes. So now, does it have an inverse? Yes. And what is its inverse? Square root of x. And now notice that gets rid of the problem I had before when I was telling you to plug in -5. I can't plug in -5 anymore because I'm only dealing with positive numbers. So the inverse of this function is square root of x. All right, so now that brings us to trig functions. F of x equals sine x. What's the inverse of sine x? I'll give you a hint. It's a trick question. There isn't one. Why not? Is sine x?
It doesn't pass.
In fact, it fails the horizontal line test really badly, doesn't it? Like infinite number of times. All right, so if I draw sine x, sine x looks like this. Does sine x pass the horizontal line test? No, it fails it really, really badly, because if I draw a horizontal line, say right here, not only does it hit more than once, how many times does it hit? It hits an infinite number of times. So sine is not a one-to-one function. It does not have an inverse. So what are we going to do? Only use part of it. Well, what I want to use is I want to use as much as I can. I really, really want to get one complete cycle. But we have to be careful on how we pick that cycle.
What do you have to do with the middle 50%? Because that would be the only way.
With the
Like if it was normal, say it was our period was too high, then we would only be able to do from pi over 2.
with the top point divided.
Yeah.
Like of the little,
So you're saying go from here
yeah,
Yeah.
so down.
to there.
Or you could go, oh wait, yeah.
Yes. That would work. Because if I go from here to here, it does two things. One, it makes it one-to-one, because it would pass the horizontal line test. I also get all the y values. It goes from a high of +1 to a low of -1 if I go from here to here. That would work, but it's not the way it's normally done. The way it's normally done is we start right here, and we go to... Oh, I'm sorry. I thought you wanted me to go from here to here. Okay. So if you said start there and go to there, then you were absolutely correct. So if I go from here to here, is sine 1-to-1 between those 2 points? Yes, it passes the horizontal line test. And notice I get all the y values. So I get my lowest y value. My lowest y value is -1. I get my highest y value, that's 1. I get all the y values. So where is this right here? And where is this right here? All right, the y values we know. The y values are 1 and -1. What are the x values? This one's pi over 2. And this one's -pi over 2. All right, so here's the right question. If I have f of x equals sine x, and x is limited to between pi over 2 and negative pi over 2, then I do have an inverse. What's the inverse? What's that? X over sine? No. Negative sine? No, that would be the opposite. Cosecant would be the reciprocal. The inverse, we have two different symbols for it. It's written this way sometimes, sine inverse of x, just like we used a little negative 1 exponent. But again, this little, when we're dealing with functions, this little thing isn't really an exponent. It doesn't mean properties of exponent. It doesn't mean put it on bottom. Or sometimes it's written this way, and called arc sine of x. You see those two symbols. All right, so if I'm dealing with sine, what's my domain? What kind of numbers can I plug into sine? I can plug in all numbers, that's true. However, if I want sine to have an inverse, what numbers can I plug in? No. What are the x numbers that I can use for sine in order for it to have an inverse? It's written right up there, isn't it? The x numbers I can use are negative pi over 2 to pi over 2. What's my range? What kind of answers am I going to get for sine? When I plug numbers into sine, what kind of answers does it give me? The y values for sine, the lowest y value, ooh, I'm missing a minus sign right there. The lowest y value is negative 1. The highest y value is positive 1. All right, how about arc sine? What numbers can I plug in for x for arc sine? What does the inverse do? Inverse flips the x's and the y's. So what numbers can I plug into arc sine? I can plug in numbers between negative 1 and 1. Those are the numbers I can plug into arc sine. What kind of answers am I going to get out? I'm going to get answers between negative pi over 2 and pi over 2. So you're thinking about the graph. What does the graph look like? Yeah, it does exactly what you just said. Yeah, in fact, it flips it over the line y equals x that we talked about before. So what's the graph going to do? It kind of goes that way. It kind of takes the sine curve and it rotates it 90 degrees in a sense, I think. Well, let's try it on the calculator, I suppose. Y equals, notice that there's an arc sine button. Where's the arc sine button? It's on the same button as sine. It's the inverse. So I want my window to go between, let's see, the only x's I can use are between negative 1 and 1, and my y values are going to be between pi over 2 and pi over 2. Now let's just see what that looks like. It looks kind of like that, I suppose. Almost looks like a line there. I don't have a good window. It's not really a line. Something like that. Anyway. So far this semester I've asked you questions like, what's the sine of pi over 6? and you have this chart in your head that you've memorized, and you look in your mind's eye and you tell me the sign of pi over 6 is?
The 1/2.
1/2. You sure? Not square root of 3 over 2?
It is 1/2.
Can't talk you out of it?
No.
Darn. 1/2. So today I'm going to ask you questions like, what's the sine inverse of a half? So now you're using that chart backward. I'm giving you the answer. I'm giving you the 1/2. You need to go back to the chart and look on the top to see what that number was, where it came from. And the answer is pi over 6. All right, so I might ask you, what's the sine of minus pi over 4? And you would do two things. First off, you would say, oh crap, that negative sign. What's that negative sign do? It makes it negative because our angle, negative pi over 4, where's that angle? It's in quadrant 4. And in quadrant 4, sine is negative. So it's going to be a negative answer. Not square root of pi over 2. Square root of 2 over 2. So you look on that chart that you've memorized. Sine of pi over 4 is square root of 2 over 2. So today I would ask you, what's the arc sine of negative square root of 2 over 2? Negative pi over 4. Very good. What's the arc sine of 1? Pi over 2 or 0?
0.
Him? Pi over 2? How many people vote for pi over 2?
Arc sine of 1.
Yeah, you look at that chart that you've memorized. Sine of which of those numbers up on the top?
1 over 6 pi over 4 over.
You get your chart backward. Your chart starts at 0. 0, pi over 6, pi over 4, pi over 3, pi over 2. The answer is pi over 2. Sine of pi over 2 gives me 1. Arc sine of negative square root of 3 over 2. I'll give you a hint. It's got a pi in it. Useful, aren't I? All right, so again, think of that chart that you've memorized. Forget about the minus sign for a minute. Is it pi over 3? It is pi over 3. And then what's this minus sign going to do? Make it negative because I need my angle to be in quadrant number 4. Because sine is negative in quadrant number 4. Questions on that? Good so far? It's like thinking backward today. I know, that's why it takes so long. Yeah, all right. Let's go for the hard questions. Arc sine of the sine of pi over, I don't know, give me a number you like. 2, 4, 6, 8. All right. Pi over 8. Why is it pi over 8? Arc sine and sine are inverses. What do arc sine and sine do to each other? They cancel. So the answer is pi over 8. Oh, so the teacher was lying when he said now come the hard ones? Maybe. All right. How about the arc sine of the sine of 5 pi over 6? 5 pi over 6 cannot be the right answer. Because when I use arc sine, what kind of answers can I get? Between negative pi over 2 and pi over 2. Where's 5 pi over 6? It's past pi over 2, isn't it? So 5 pi over 6 cannot be the right answer. Is it pi over 6? Yes. Why pi over 6? Ah, 5 pi over 6 is in quadrant 2, isn't it? And what can you tell me about sine in quadrant number 2? It's positive, isn't it? So this is exactly the same as the arc sine of the sine of pi over 6. So you got to watch out for that. Sometimes you're not given angles in the right zone. When the angles are not in the right zone, you've got to fix them and put them in the right zone. 5 pi over 6 is not in the right area. It's not between minus pi over 2 and pi over 2. I have to rewrite it. So the answer is pi over 6. How about the arc sine of the sine of 5 pi over 4? It would just be pi over 4. That's close, but not correct. Negative pi over 4 is correct. Where did that negative come from?
Because it's in the third quadrant.
5 pi over 4 is in the third quadrant. And a sign positive or negative in the third quadrant?
Negative.
It's negative. So what I really want here is I want arc sine of the sine of minus pi over 4. Why do I use minus pi over 4? Because this is in quadrant 4 and sine is still negative in quadrant 4.
Negative square.
Which is negative square root of 2 over 2, and then when I do arc sine, I just get minus pi over 4, because minus pi over 4 is in the right zone. Alright, so watch out for those. It's very easy to think arc sine and sine are just going to eliminate each other. They do when your angle's in the right zone, like pi over 8 is. If your angle is not in the right zone, you've got to deal with a reference type thing and get it in the right zone before you can cancel them out. Questions on that? Okay. How about the sine of the arc sine of a half? I hear a reluctant vote for 1/2. Do I hear a confident vote for 1/2? 1/2. All right. Why is it 1/2? Sine and arc sine are inverses. They reduce each other. So the answer is 1/2. How about the sine of the arc sine of 3/2?
It has to be equal to sine of arc sine of negative 1/2.
No. Isn't it not possible? Why would you say not possible? What I really want to do is I want these to reduce each other, don't I? And I really want to say the answer is 3/2. Can the answer possibly be 3/2? No, because the biggest possible answer I can get for sine is no. 1. The biggest possible answer I can get is 1. When I'm dealing with arc sine, what kind of numbers can I plug in? I can only plug in numbers between -1 and 1. Is 3/2 between -1 and 1? So the answer is undefined. Trick question, can't do it.
So why can't you do something with arc sine?
Because when I'm dealing with sine, what numbers can I plug into sine? Any number in the whole world, correct? The only thing is, in order to deal with the arc sine, I need to have that number be in the right spot. So if the arc sine is on the outside, I can use any number in the world in here. If the arc sine is on the inside, then I'm stuck. I can only use numbers between -1 and +1. Okay. All right, well, that was arc sine. That was a good time. How about f of x equals cosine x? Is cosine x a one-to-one function?
No.
No, it is certainly not. It's just as bad as sine. It fails an infinite number of times. Cosine looks like this, roughly. All right, so I want to do the same trick in the sense that I want to limit the domain. I want to limit the domain to make it a one-to-one function, and I want to get all the y values. Where do I start? At 0, 1. So I'm going to start here. And end at -1? You mean y equals -1?
Yeah.
End right there. So when we're dealing with cosine, we're going to pick that part of the graph. And that part of the graph, the function is 1-to-1. What are my points here? This is 0, 1. Where's that? It's definitely not 0, -1. It's something -1. It's not 2 pi. 2 pi is way over here. It's pi. All right, so for cosine and arc cosine, it's different. Domain, if I'm dealing with cosine, my x numbers are going to be between 0 and pi. And notice that's very different from what we had for sine. For sine, we had -pi/2 to pi/2. For cosine, we have to use 0 to pi to make it 1-to-1. If I were to use -pi/2 to pi/2, would it be 1-to-1? No, because -pi/2 would start right here. -pi/2 to pi/2 would be that hump. It would not be 1-to-1. It wouldn't be any good. Okay? What's my range when I'm dealing with arc cosine? When I'm dealing with cosine, what kind of y numbers do I get? Still -1-to-1. So when I deal with arc cosine, what numbers can I plug in for x? -1-to-1. And when I use arc cosine, what kind of y numbers am I going to get? I'm going to get y numbers between 0 and pi. Okay. So again, I got that big chart that I've memorized in my head. I like this chart a lot. I've used it every day, it seems like. What's the arc cosine of 1/2? Pi/6, I heard reluctantly.
Yeah.
It's pi/6? Sure?
Yeah.
You sure it's not pi/3?
Yeah, it is because I was looking at the sign.
It's what one? It is pi/3. Definitely
I was
pi/3.
still looking at the sign.
You were still looking at the sine one in your head, yes. Remember, cosine starts at 1 and cosine gets smaller.
Yeah.
So cosine gets to 1/2 near the end of it, which is down at pi/3. What's the arc cosine of -1/2? It cannot be -pi/3 because when I'm dealing with arc cosine, my answers have to be between 0 and pi. So, arc sine is easier than arc cosine. Because if I give you an arc sine thing and the thing is negative, you just get to make your answer negative. Arc sine is easier than arc cosine, unfortunately. It can't be negative pi over 3 because negative pi over 3 is in quadrant 4 and cosine is positive in quadrant 4. So what I need is I need the angle in quadrant number 2, because cosine is negative in quadrant number 2, that has a reference angle of pi over 3. So what's the angle in quadrant 2 whose reference is pi over 3? 2 pi over 3. 4 pi over 3 is too big. 4 pi over 3 is bigger than pi. So it's 2 pi over 3. So arc cosine is more difficult. Because arc cosine, if you have negatives, you have to convert everything to quadrant 2. Arc sine is easy. Converting to quadrant 4 is easy. Put a minus sign in front of it. Arc cosine is a pain in the neck. All right, so let's do some more of those. As long as they're hard. Arc cosine of minus square root of 2 over 2. Well, I look on my chart. The way I begin, I look at my chart for square root of 2 over 2. That's pi over 4. But now I notice I got a negative here, so I got to move this angle to quadrant 2. So how do
always be to quadrant 2 for negative?
if you're dealing with arc cosine, it will always be quadrant 2. Because, again, we're dealing with angles. Where's the right sheet? There it is. We're dealing with angles between 0 and pi. So that's 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. So for arc cosine, it will always be quadrant 1 if things are positive, quadrant 2 if things are negative. Okay, so what's the angle in quadrant 2 whose reference is pi over 4? 3 pi over 4, correct. So our answer will be 3 pi over 4. Who comes up with these things? Well, nobody comes up with these things. People looked at the picture and said, look, if I need this sucker to be 1 to 1, I've got to go from here to here. It's the only way to do it. Well, it's not the only way, but it's the easiest way. Somebody could have been really mean and say, I'm going to go from here to here, which would be pi to 2 pi, which means I'm going to use angles in quadrant 3 and quadrant 4. That would have been mean. We decided to do it the easy way and go here to here. But it's still harder than sine, unfortunately. What's the arc cosine of negative 1? Now, cosine of 0 would give me positive 1. Pi is correct. Cosine of pi would give me a negative 1. So the arc cosine of negative 1 is pi. All the way to the end. All the way over halfway across. What's the arc cosine of negative 4? Not 0. Not 2 pi. Undefined. Why undefined? What kind of numbers can I plug into arc cosine? Only numbers between negative 1 and positive 1. Is negative 4 between negative 1 and positive 1? No, another trick question. This is undefined. Quite often it's written that way. Sometimes you'll see that, although that's really not the symbol for undefined, but people use it and I'll accept it. That's really the symbol for the empty set. But close enough. All right, how about the arc cosine of the cosine of, give me an angle that you like, pi over 2. What's the arc cosine of the cosine of pi over 2? Is pi over 2 in the right zone? What's the right zone for cosine again? The right zone is between 0 and pi. Is pi over 2 between 0 and pi? Yes. So since pi over 2 is in the right zone, these things kill each other. And the answer is pi over 2.
Yeah, I'm just like,
Well, there's a lot of second guessing that goes on in this section. This is, in my opinion, one of the most difficult sections. One of the most challenging sections. And we're only about halfway through it. We're not going to finish it today. And I knew we weren't going to finish it today. What's the arc cosine of the cosine of minus pi over 2? Is minus pi over 2 in the right zone? No, it is not in the right zone. So we gotta put it in the right zone. Well, let me ask you a different question then. If it's in the right zone, like pi over 2 was, we just get to cancel these out and write the answer. If it's not in the right zone, we got to do more work. What is the cosine of negative pi over 2? No. No, cosine of regular pi over 2 is 0. Where is negative pi over 2? No. Not in quadrant 4. It's on the axis. Minus pi over 2 is right there. Pi over 2, this is pi over 2. This is minus pi over 2. On my unit circle, what are the x numbers and the y numbers right there? 0, negative 1. So what's the cosine of negative pi over 2? 0, because cosine is the x value. So this is arc cosine of 0. The arc cosine of 0 is pi over 2. Cosine of pi over 2 gives you 0. All right, one more.
So if it's,
Go ahead.
if it's written as arc cosine of negative, just positive counterpart?
Oh, that would be too easy.
I know.
What's the arc cosine of the cosine of negative 5 pi over 6? Is negative 5 pi over 6 in the right zone? Yeah, no, it's not. Because it's got to be between 0 and pi. Where does negative 5 pi over 6 live? Which quadrant? It's in the third quadrant, isn't it? Negative 5 pi over 6 is here. In the third quadrant, is cosine positive or negative? It is. Cosine is negative in quadrant number 3. What's that? So the reference angle is pi over 6, and the cosine of negative 5 pi over 6 is negative square root of 3 over 2. That's correct. So this is the arc cosine of negative square root of 3 over 2. So now I'm dealing with something that's negative. What's my answer? Well, I look in the chart that I've memorized. Where's square root of 3 over 2 for arc cosine? It's at pi over 6. Except this minus sign tells me what? It's got to be in the second quadrant. So it's 5 pi over 6. Lots of quadrant chasing, lots of looking at that chart. Lots of homework due Tuesday. Don't forget, 2 sections. I will see you on Wednesday. If you go to WebAssign and you log in, right here under announcements, and so there's all of them. So you can just click on one of these and it'll take you to the video. Okay?